Our Earth is a remarkable place, teeming with life in countless forms. From the tiniest microorganisms to the largest mammals, life thrives in every corner of our planet. The diversity of life is a testament to the resilience and adaptability of living organisms. Each species, no matter how small, plays a crucial role in maintaining the balance of our ecosystems. From lush rainforests to scorching deserts, our planet boasts a stunning diversity of landscapes and creatures. These varied environments provide unique habitats that support a wide range of life forms. In the rainforests, the dense canopy shelters countless species, while the arid deserts challenge life to adapt in extraordinary ways. Each landscape tells a story of survival and evolution, but have you ever wondered what our world was like billions of years ago, long before the dinosaurs roamed the Earth? Imagine a time when the planet was a molten mass, with volcanic eruptions shaping the surface. The air was thick with gases, and the oceans were just beginning to form. It was a world unrecognizable to us today, devoid of the life we now see. Journeying back in time to Earth's early history is like exploring an alien planet. The surface was dominated by volcanic activity, with lava flows creating new landmasses. The atmosphere was toxic and the conditions were harsh. Yet it was in this seemingly inhospitable environment that the building blocks of life began to emerge. The early Earth was a crucible of chemical reactions that set the stage for the development of life. 4 billion years ago, our planet was a vastly different place. The young Earth was a dynamic and volatile world, with constant geological activity reshaping its surface. The oceans were forming, and the first continents were beginning to take shape. It was a time of intense change and transformation, laying the groundwork for the complex ecosystems that would eventually arise. Understanding this early Earth is crucial to comprehending the origins of life itself and the evolution of our planet over eons. By studying ancient rocks and geological formations, scientists can piece together the history of our planet. These rocks hold the secrets of Earth's past, revealing clues about the conditions that led to the emergence of life. Each discovery brings us closer to understanding the incredible journey of our planet. By piecing together clues from ancient rocks and fossils, scientists are gradually uncovering the secrets of our planet's distant past. Fossils provide a window into the lives of ancient organisms, showing us how life has evolved over millions of years. Each fossil is a piece of the puzzle, helping us to reconstruct the history of life on Earth. The work of paleontologists and geologists is like detective work, solving the mysteries of our planet's history. It's a journey through deep time, revealing a story of dramatic transformations, remarkable adaptations, and the very beginnings of life as we know it. The history of our planet is a tale of constant change, with life continually adapting to new challenges. From the first simple organisms to the complex ecosystems we see today, the story of life on Earth is one of resilience and innovation. As we continue to explore and understand our planet's past, we gain a deeper appreciation for the incredible journey that has brought us to where we are today. Today we take a breath without a second thought, our lungs filling with life-giving oxygen. This simple act is so fundamental to our existence that we rarely pause to consider the complex history of the air we breathe. The atmosphere as we know it is a delicate balance of gases that has evolved over billions of years to support life. But it wasn't always this way. But 4 billion years ago, taking a breath on early Earth would have been lethal. The planet was a vastly different place, a hostile environment where the air was unbreathable for any form of life as we know it today. The atmosphere was a toxic cocktail devoid of oxygen and thick with noxious gases like methane, ammonia, and carbon dioxide. These gases were released in massive quantities from the planet's interior, creating a suffocating blanket around the young Earth. This early atmosphere was a product of intense volcanic activity which spewed out gases from the Earth's interior. Volcanic eruptions were not just occasional events. They were a constant feature of the landscape, shaping the planet's surface and atmosphere. Volcanic eruptions were commonplace, painting the skies with fiery hues and blanketing the land in lava flows. These eruptions released vast amounts of gases and particulates into the atmosphere, contributing to the thick, toxic air. It was a world in constant geological turmoil, a far cry from the relatively stable environment we enjoy today. The Earth's crust was still forming, and the surface was a chaotic mix of molten rock and solidifying land masses. This alien atmosphere had a profound impact on the planet's climate and the development of life. The thick blanket of gases trapped heat, creating a greenhouse effect that kept the planet warm despite the faint young sun. Without an ozone layer to shield the surface from harmful ultraviolet radiation from the sun, the land would have been bathed in intense radiation. This radiation would have been deadly to most forms of life, making the surface of the planet a harsh and inhospitable place. The lack of oxygen, essential for most life forms today, meant that early life had to evolve unique ways to survive. Primitive organisms, known as extremophiles, thrived in these harsh conditions, finding ways to harness energy from the chemical-rich environment. These early life forms, such as microbial mats and stromatolites, played a crucial role in transforming the atmosphere. Through the process of photosynthesis, they began to produce oxygen, slowly altering the composition of the air. Cyanobacteria, one of the earliest photosynthetic organisms, were particularly important. They flourished in the ancient oceans, creating vast colonies that pumped oxygen into the atmosphere over millions of years. This gradual increase in oxygen led to the Great Oxygenation Event, a pivotal moment in Earth's history. The rise of oxygen not only changed the atmosphere, but also paved the way for the evolution of more complex life forms. With more oxygen available, life on Earth began to diversify. Multicellular organisms emerged, leading to the rich tapestry of life that we see today. The transformation of the atmosphere was a key factor in this evolutionary explosion. Today, we live on a planet with a stable atmosphere that supports a diverse array of life. The air we breathe is a testament to the incredible journey of our planet, from a hostile, toxic environment to the life-sustaining world we call home. Imagine a world devoid of the familiar sights of life. No lush forests, no colorful coral reefs, no animals roaming the land. This was the stark reality of Earth 4 billion years ago. The landscape was a desolate expanse of volcanic rock, constantly reshaped by volcanic eruptions and meteor impacts. Oceans, still in their infancy, were hot and acidic, a far cry from the life-teeming waters we know today. The land masses, if they existed, were small and fragmented, constantly shifting and colliding due to the planet's dynamic geology. This was a world in a constant state of flux, a landscape sculpted by fire and fury. Yet, amidst this seemingly inhospitable environment, life was beginning to take hold, paving the way for the remarkable diversity we see today. Section 4. Hints of Life, the First Pioneers. Despite the harsh conditions of early Earth, life in its most basic form emerged. The planet was a hostile place with volcanic eruptions, meteor impacts, and a toxic atmosphere. Yet, in the midst of this chaos, the first signs of life began to appear. These early conditions were far from the lush green landscapes we are familiar with today. Instead, the Earth was a barren, rocky terrain, shrouded in dark skies and filled with the roar of volcanic activity. These early life forms were not the complex plants and animals we see today. The diversity of life we now observe, from towering trees to intricate coral reefs, was unimaginable in those primordial times. The first life forms were incredibly simple, lacking the complexity and specialization that characterize modern organisms. Instead, they were simple, single-celled microorganisms, similar to bacteria. These microorganisms, known as prokaryotes, were the pioneers of life on Earth. They were incredibly small, yet they played a monumental role in shaping the future of life on our planet. Their simplicity was their strength, allowing them to thrive in the harshest of conditions. These hardy pioneers, known as prokaryotes, thrived in the extreme environments of early Earth. They colonized areas that would be inhospitable to most modern life forms, such as volcanic vents and hot springs. These environments were rich in minerals and provided the perfect conditions for these microorganisms to flourish. They evolved to survive in the absence of oxygen, relying on alternative energy sources like sulfur and iron. This ability to utilize different energy sources was crucial for their survival, as the early Earth's atmosphere lacked the oxygen that many modern organisms depend on. By harnessing the chemical energy from their surroundings, these prokaryotes were able to sustain themselves and proliferate. Evidence of these early life forms comes from fossilized remnants found in ancient rocks, some dating back nearly 4 billion years. These fossils provide a window into the past, allowing scientists to piece together the story of life's origins. The discovery of these ancient fossils has been instrumental in understanding how life began and evolved on Earth. The discovery of these microscopic fossils was a groundbreaking moment in our understanding of life's origins. It confirmed that life had existed on Earth for billions of years, surviving through some of the most extreme conditions imaginable. These tiny fossils have provided invaluable insights into the resilience and adaptability of life. It showed that life could arise even in the most extreme conditions, hinting at the possibility of life existing elsewhere in the universe. If life could thrive in the harsh environments of early Earth, it raises the exciting possibility that similar life forms could exist on other planets with extreme conditions. This discovery has fueled the search for extraterrestrial life, as scientists continue to explore the potential for life beyond our planet. Section 5. The puzzle of photosynthesis. Breathing life into the planet. The emergence of photosynthesis was a pivotal event in Earth's history, transforming the planet and paving the way for the evolution of more complex life forms. Photosynthesis is the remarkable process by which certain organisms, like plants and algae, convert sunlight into energy, releasing oxygen as a byproduct. Early photosynthetic organisms, likely similar to cyanobacteria, began to release oxygen into the atmosphere. Over millions of years, this oxygen accumulated, gradually transforming the toxic atmosphere into the oxygen-rich air we breathe today. This great oxidation event was a turning point in Earth's history. It allowed for the evolution of aerobic organisms which use oxygen for respiration, and eventually led to the development of more complex life forms, including animals.